There's a tornado right there. Guys, everybody go.
The wind started howling and you could hear the roar coming.
Looks like a 5,000-pound bomb hit the middle of town.
Imagine a thunderstorm so powerful it can last for hours, unleashing hail the size of baseballs, generating tornadoes that flatten entire neighborhoods, and still finding the strength to keep going. This isn't your average summer thunderstorm. This is a supercell, the rarest and most dangerous type of storm on Earth. But what exactly makes these giants form? Why do they behave so differently from the ordinary storms that quickly fall apart? Today, we're breaking it down step by step, and by the end of this video, you'll understand why supercells are both meteorological marvels and nature's most destructive storms. Most thunderstorms are messy, short-lived, and chaotic. They bubble up, dump some rain, and collapse in under an hour. A supercell, however, is something entirely different. At its heart is a rotating updraft, known as a mesocyclone. Imagine a massive corkscrew of rising air, 2 to 6 miles wide, spinning at the core of the storm. That rotation is what gives the supercell its incredible longevity. Unlike normal storms, it doesn't collapse on itself. Instead, the rotation separates the rising warm air from the falling rain and hail, allowing the storm to feed continuously on moist air near the surface. This is why nearly every supercell produces large hail, damaging winds, and in about 30% of cases, tornadoes. Now, like all thunderstorms, supercells need 3 basic ingredients to even exist: moisture, instability, and lift. Moisture is the storm's fuel source, warm, humid air near the ground. When that air rises and condenses into clouds, it releases heat, supercharging the updraft. Instability is the atmosphere's willingness to let air rise. Meteorologists measure this with something called CAPE, or convective available potential energy. High CAPE means the atmosphere is primed for explosive growth, where warm surface air rockets upward through cooler air above it. But even with moisture and instability in place, the atmosphere still needs a trigger. That's where lift comes in, a cold front pushing through, a dry line separating moist and dry air, or even mountains forcing air upward. Together, these 3 ingredients create thunderstorms. But they don't guarantee a supercell. For that, you need one final critical factor: wind shear. Wind shear is the secret sauce. It's the change in wind speed and direction as you move higher into the atmosphere. Near the ground, winds might be gentle and southerly, but a few thousand feet up, they're stronger and blowing from the west. This difference creates invisible tubes of rolling air, like barrels spinning horizontally across the landscape. When a powerful updraft forms in a thunderstorm, it tilts those tubes upright, transforming them into a rotating column of air, the mesocyclone. That's the birth of the supercell. Wind shear also tilts the updraft itself, pushing rain and hail away from the storm's core. Without this tilt, precipitation would fall back into the updraft and choke the storm out. With it, the storm stays clean, organized, and incredibly resilient. Inside a mature supercell, the structure is breathtakingly complex. At its center, the mesocyclone rises skyward like a colossal corkscrew. Beneath it, storm chasers often see a wall cloud, a lowered, rotating base that can spawn tornadoes. Around the storm, 2 major downdrafts form: the forward flank downdraft, which carries rain and hail ahead of the storm, and the rear flank downdraft, which carries rain and hail behind the storm downdraft, a rain-cooled current of air wrapping around the back. Sometimes a flanking line develops, a chain of smaller clouds feeding into the main storm, resupplying it with fresh, warm air. Inside the mesocyclone, updraft speeds can exceed 100 miles per hour. That's what allows hailstones to grow to massive sizes, suspended and coated with layers of ice before gravity finally wins. And when conditions align just right, That mesocyclone can tighten into a tornado, releasing some of the most destructive energy on the planet. Supercells are rare, but they matter more than their numbers suggest. While they represent only a fraction of thunderstorms, they are responsible for most of the largest tornadoes, the biggest hail, and some of the fiercest winds ever recorded. That's why meteorologists and storm spotters track them so closely. On radar, they reveal themselves with distinctive signatures like hook echoes, swirling shapes that warn of potential tornadoes. In the field, storm chasers look for persistent rotation, wall clouds, and that ominous organized structure that screams supercell. These observations save lives, giving communities precious minutes of warning before disaster strikes. So, why do supercell storms form? It happens when the atmosphere aligns in just the right way. Plentiful, warm, moist air at the surface, strong instability that encourages air to rise, a trigger to get it moving, and above all, powerful wind shear that spins and organizes the storm. The result is nature's most sophisticated and destructive thunderstorm, a storm that can last for hours, evolve cyclically, and unleash chaos across the landscape. If you found this breakdown fascinating, hit that like button. It helps us reach more people who are just as captivated by the power of storms. Don't forget to subscribe to Nature Unleashed for more deep dives into the science and spectacle of extreme weather. And remember, storms are incredible to watch, but they demand respect. Stay safe, stay informed, and never underestimate the power of nature.